Hi everyone, I continue on the lesson. Um, Point of inflection. Point of inflection is the point. So here is definition. Is the point that concave changes from up to down. So concave, or the form of the function, changes from a ball to a hat somehow. Okay. So here is here is point of inflection. Look at this function. See, all of a sudden at this point, the point of inflection, the concavity of the function changes from up to down here. So it changes from a bowl to a hat. Okay. So here we say this is inflection point. So I can see, and I can say if I have second derivative positive, concavity is up. And that's why I said if you have second derivative positive, you have minimum. If you have second derivative negative, concave is down. And that's why I said negative gives you maximum. Okay? So here I can link them. So this guy with up and this guy is with down. Right? Okay, so if I say positive concave is up, negative concave is down, what can I say about 0? Maybe I can say at 0, concave changes. And at 0, I can find my inflection point. Inflection point is where the form of the function changes, or concavity changes from up to down, down to up. Okay, so I can find second derivative. I can find where second derivative is 0. Okay, I can do it on this example. In order to find second derivative, I have to find first derivative at the beginning. So this is 6x squared plus 4x, plus 2x. Second derivative is 12x plus 2. Second derivative is 0 at this point. Okay? At this point. Minus 1 over 6. Can I say for sure this is inflection point? You are not here to answer me. So, I answer no. Why? Because I have to check if concave changes. I didn't say inflection point is where the second derivative is 0. No, I said concave changes from up to down. So you have to check if concavity change. So this is second derivative, right? Good. So I find minus 1 over 6 here. I can tell you a method in mathematics that you can see when you have 0 at a point, where do you have positive or negative? Of course, I don't have any other choices. It's either positive or negative. Okay? So 0 at this point, positive, negative. Okay, so how do I say? I can tell you a method, but I don't want to go to those details. So you can check a point. Find a point after and find a point before this. After, I can check 0. So here you have to have good sense of numbers. Here I have minus 1. Because minus 1 over 6 is between those two numbers. Now I check 12 times minus 1 plus, must be 2, right? Plus 2 is negative. So concave is down. 12 multiple 0 plus 2 is positive. So concave is up. Okay? Because concavity changes, so the concave change from top to bottom, top to down, down to top, then I can say yes, I have inflection point. Not just because the second derivative is 0, no. Then it's asking for concave in these points. So you have to check 12 times minus 1 plus 2 Okay, I don't know what's wrong with this. Yeah, 12 times minus 1. I hope nothing is wrong with the pen, as we will have issues. Okay, so 12 times minus 1 plus 2, which is negative. Yes, concave is down. And for this, 12 times minus 2 plus 2, which is, yes, still negative, so concave is down for both of them. Okay, for both these points. Can I say this is inflection point at minus 1 over 6? I can say inflection point happens in x equal minus 1 over 6. But I cannot say inflection point is that point. I have to say y. I have to check what is y. Look at here. Inflection point is somehow here. So I need to find y. What is y? So y is something between minus 2 and minus 4. How can I find it? I have to substitute minus 1 over 6 in the original function. So 2 times minus 1 over 6 cube plus minus 1 over 6 squared minus 3. So I can find the answer here. Okay, so 2 times, unfortunately I don't have those notes, so I can find it here. So 2 times bracket this minus 1 over 6 power 3, that's cubed, plus that's squared minus 3, which is minus 2 point, okay, so this is minus 2.98. Okay, so I can say, or I can show my number in a fraction. That's good. That's totally, that's more correct. Okay, that's better. Okay, so here I use my calculator, so it gives me decimal. So here, okay, look at this. Yes, makes sense. It's close to 3, minus 3. Okay, so I can say inflection point is minus 1 over 6, comma, minus 2.98. Okay, correct, and much better if I show in fraction. I didn't want to waste your time, so I used the calculator. Here, again, I said when you have inflection point, you have second derivative equals 0. Okay, but it doesn't mean if second derivative is 0, for sure you have inflection point. Look at this graph. This graph is y equal x power 4. First derivative is 4x power 3. And second derivative is 12x squared. If I put equal 0, I find x equals 0. Okay, nice. But at this point, inflection, at this point, concave doesn't change up to down. Because look at this. Before a 0 and after 0, this guy is always positive. So concave is always up. So it doesn't mean if the second derivative is 0, for sure you have inflection point. No. Second derivative must be 0, and then you have to check if concave changes from up to down, down to up. How? If second derivative changes from minus to positive and positive to negative. Okay? In order to find where concave may change from positive to negative, okay, you have to see second derivative equals 0. But it doesn't mean second derivative is enough for you. Being 0 for second derivative, having 0 for second derivative is not enough. In mathematics, we say it's necessary but not enough. Okay, so that's necessary but not enough. I need more conditions. Okay, so just practice questions. Find critical points. Okay, so I just do a step by step, and I want you to listen. So critical points. For critical points, first derivative equals 0. I told you, definition of critical points are those points that they make first derivative equal 0, or first derivative doesn't exist. But you don't see those points, you don't see those functions in this math. Okay, if you go to university, yes, you see more details. Yeah. Okay, so first derivative equals 0. So first derivative is step by step. First derivative is 3x squared minus 3. Y prime equals 0. X squared equal 1. So step by step, 3x squared minus 3 equals 0. So 3x squared equal 3. X squared equal 1. X is plus minus 1. Okay, for x equal 1, y is 1 minus 3 minus 2 plus 4 is 2. And for x equal minus 1, y is minus 1 plus 3, 2, and 6. Okay, so I have two inflection points, one of them 1 and 2, one of them minus 1 and 6. Let me make sure if I have, let me see, if I use minus 1 plus 3, 2, and 4, 6, yes. Okay, so I can go to the, yeah, 6 and 2. Okay, so these are my inflection, so critical points. Okay, how about points of inflection? Okay, for points of inflection, I have to find second derivative. Second derivative is 6x. Second derivative is 0 at x equals 0. But I cannot say x equals 0 and 4. I put 0 there and find 4 for y. This is my inflection point. No, I have to see if y double prime or 6x, which is y double prime, changes at this point from positive to negative, negative to positive. Okay, here is 0. Before this, 6x is negative, and after this, positive. So concave changes from down to up, up to down. See, concave, I show this way. Decrease, increasing, decreasing, I show this way. Okay, these are just, they're not like each other. No, one of them is straight, one of them is not. Okay, so, okay, look at this. Look at this. See, I have inflection point. Sorry, I have critical points here. I didn't talk about maximum, minimum. Okay, so you don't need to continue on this question. But these are critical points. Critical points, and here is points of inflection. Points of inflection is, look at this, where concave changes. See, concave is down and goes up. Okay. So yes, here I have to write points of inflection like that. Points of inflection. And also I can show it here. POI. Okay. Yeah. How about this question? I have a second one. Do I have yes, for both of them I need to do the same thing here. Yeah, it's okay, I can do that. Okay, so y prime is 6x squared minus 18x plus 12, which is 6 times x squared minus 3x plus 2 equals 0. Remember, I'm not forgetting this, because many times I ask a student to simplify or factor, they just remove 6. No, I just take it out. I just factor. But when I say equal 0, I don't need to consider 6 because 6 is not 0. So when in multiplication I have something equal 0, either 6 is 0 or the other one is 0. So 6 is not 0, so the other one is 0. So I say x squared minus 3x plus 2 is 0. Okay, so I have 2 points. One of them is, I think it is x minus 1. X is 1 and 2, I think. So if I put x is 1 and x is 2. Okay, if x is 1, I have 2 minus 9 minus 7 plus 12, 5. Okay, 2 And if it's 2, y is, if it's 2, I put 16 minus 36 plus 24 minus 3, which is 1. Okay, so I have 2 points. One of them is 1 and 2, one of them is 2 and 1, and they are both critical points because they both make first derivative 0. First derivative is 0 at x, of course, but you have to find y because those points are on the graph. So we don't just talk about x. How about second derivative? Second derivative is 12x minus 18. So x is 18 divided by 12, which is, let me see if I, 3 over 2? Yeah, 3 over 2, 1.5. Okay, so second derivative at 3 over 2. Second derivative is this. At 3 over 2 is 0. After, I can check 2. Before, I can check 1. You have to have a good sense of numbers. 3 over 2 is 1.5. So you need to find something after. And usually a student, they make mistake in negative numbers, be less than and more than. And when they have fraction. So I recommend use your calculator to find the number in decimal, and then you can see what is less than, what is more than. Okay, here when you put 2, 12 at 2 minus 18 is positive, concave up. 12 at 1 minus 18 is negative, so concave is down. So yes, 3 over 2 is point of inflection. Or I can say 3 over 2 is where point of inflection happens, because I have to find y. Okay, so now I check. So 2 times 1.5 cubed, here is easy because just 1.5, minus 9 times 1.5 squared plus 12 times 1.5 minus 3. I think the answer is 1.5. Yeah. Okay, so 1.5 and 1.5. So this point is point of inflection, because first of all, second derivative is 0 at here, and second derivative changes from positive to negative. Sorry, from negative to positive, or positive to negative. So okay, look at this. This is critical point, this is critical point, and here in the middle, see, concave changes. So that's inflection point, point of inflection. Here is summary of the lesson. I can just tell you in detail here. Critical points. Critical points are where you have first derivative 0. I told you definition has more explanation, but you don't see in this college. So in this course. Make sure you solve for x and find y. And those points are critical points. Okay. If first derivative is positive, you have increasing. First derivative negative, you have decreasing. So in order to find increasing and decreasing, you have to find first derivative equals 0. And then check before and after those points. You don't have any other option, either positive or negative. So either increasing or decreasing. For maximum minimum, you can do step 2 as well, increasing, decreasing, but it's time consuming. So I recommend find second derivative. If second derivative is positive, minimum. If second derivative is negative, maximum. Remember, negative, maximum. How about point of inflection? Find first derivative equals 0, okay? And check if concave changes from up to down, down to up. Okay? How? You have to check second derivative is positive, changes from positive to negative and negative to positive. So positive concave up, negative concave down. Okay? So Yeah, it's just explaining. Okay, so here. Okay, so I wanted to make it easy for my students, so I have one question for each step. Okay, so I think this is the question that we did already, because it's 3x squared minus 3. Yes, x is plus minus 1. So we did this. Okay, so this is just a step by step. So in order to find first derivative, sorry, in order to find critical points, you can just do it as a practice. Critical points, because I did it already. So find first derivative equals 0, and then find those points. Okay, find y. So everything is explained here. Okay, step by step. In order to find maximum, minimum, do this second derivative. Okay, second derivative, positive, minimum, negative, maximum. So how about increasing, decreasing? I find first derivative and see if first derivative changes from positive to negative, negative, positive. Then I can say increasing, decreasing. Okay, so I can just see here. I can do it. See, I have, for this I can do it, x cube, yeah, x cube minus 3. So look at this, x, here I have, yeah, this one here. Okay, so x cubed minus 3x, right? Am I right here? Yeah, so that's my function. Okay, so now first derivative is 3x squared minus 3. First derivative is 0. At what point? Minus 1 and plus 1. Look at this. First derivative is 3x squared minus 3. Remember, I have 2 points. Which one is smaller? I have to bring that one first, because based on number line, I go from small to large. Okay, minus 1, 1. At these 2 points, first derivative is 0. Before minus 1, I have to check a point, so I have to check minus 2. Between minus 1 and 1, I have to check 0, because it's easier for me. After 1, I check 2. If I put minus 2, I see y double, so y prime at minus 2 is positive. So it's increasing. If I put y prime at 0, it's negative, so it's decreasing. Y prime at 2, positive. I check here. I put minus 2 here, I put 0 here, and I put 2 here for x. So how do I answer? I say from minus infinity to minus 1, and this means union in math. From 1 to infinity, I have increasing. From minus 1 to 1, I have decreasing. So you can answer this way. Okay? So in order to find critical points, find the first derivative, put equal 0, then substitute in y and find y. Those are your critical points. How can I say they are maximum, minimum? I check second derivative and I substitute there. Second derivative positive, minimum, negative, maximum. For increasing, decreasing, it's this way. Okay? Point of inflection. For point of inflection, I do second derivative. What is second derivative? Here, 6x. Okay, so second derivative is 6x. 6x equals 0, x equals 0. If I put x equals 0, what was my original function? My original function is x cubed minus 3x. Okay, so my original function is y equal x cubed minus 3x. So if I put x equals 0 there, y is 0 as well. Okay? Can I say this is point of inflection? No, I have to check second derivative. So second derivative at that point, 6x. 0, but after positive, before negative. So concave down changes to up. Yes, for sure, I can say 0 and 0 is point of inflection because concave changes from down to up. Now, if I ask you, write me where concave is down, you can say from minus infinity to 0, concave is down, and from 0 to infinity, concave is up. Look at this, and look at this. Okay? So these are all the steps. Okay, look at here. This is maximum. This is minimum. Okay? This is 1 and minus 2. This is minus 1 and 2. Let me see. I'm not sure about 2 here. Yes, if I put minus 1, yes, 2, yeah. Okay, minimum, maximum. That point is inflection point, point of inflection, because concave changes here. Okay? And that was all. Here I can use all this information in order to graph my function. Okay, I want to graph it. I need more information, of course, but here I can use this information. I can find critical points. Critical points help me to find maximum, minimum. I can find increasing, decreasing. Increasing, decreasing helps me to know where is the direction of my graph. It's going up or down. Critical points. I need to I need to check if critical points are maximum, minimum. Okay, so continue. Point of inflection. Point of inflection helps you to graph concave up or concave down, like a ball or like a hat. Okay, so concavity change helps for that. You need more information in order to graph your function very beautiful. X-intercept. X-intercept tells you where you touches x-axis, and y-intercept tells you where the graph touches y-axis. Okay, look at here. I want to make my graph. So see, I can see. Oh yes, I can see here and here. It's touching x-axis. So these are my x-intercept. Okay, I can see, and y-intercept is just 0. Okay, more information which we don't go to these details here. Vertical asymptote and horizontal asymptote. Asymptote is where the function is approaching to a number. What do I mean? So in this course you don't see those functions that are not smooth, but there are many functions that are not smooth and I want to graph them. So I need to have this information. Vertical asymptote. If I have when x is approaching to a number, function is approaching to infinity and minus infinity, I can say this is vertical asymptote. Look at this. If I graph the function of y equal 1 over x, this is the function. Look at this. Limit. When x is approaching to infinity, 1 over x is approaching to 0. We know all this from the limit that you have quiz on. Okay, see, this is my horizontal asymptote because the graph don't touch x-axis, just is approaching to x-axis. How about this side? Limit. When x is approaching to minus infinity, 1 over x is also approaching to 0 again. So this is horizontal asymptote as well. So my two horizontal asymptotes are, in both cases, is just 0, because when x is approaching to infinity and x is approaching to minus infinity, y is approaching just to 0. How about for vertical? For vertical, I can see limit 1 over x. When x is approaching to 0 from positive side, I can see the whole function is approaching to infinity. You saw all of these in limit. Here, when x is approaching to 0 from negative side, 1 over x is approaching to minus infinity. You can see it's approaching to here. This one is approaching to up, up, up. But it doesn't touch it because it's by limit. And we know it doesn't reach, just approaches. Okay? So I can say y equals 0 is vertical asymptote. Okay, so here vertical asymptote is y equals 0 and horizontal is x equals 0. Okay? You don't really see these things because the functions that we are working on are very, very smooth. So 1 over x is not defined in x equals 0, and that's a problem for us. 1 over x has x in the denominator, and when x approaching to minus infinity and infinity, that makes issue for you. Okay, so that's not a smooth function. We don't really use those things, but you can have information about them. Okay, so I am done with this lesson and I am done with this video. I continue either tonight or tomorrow. I continue on the lesson to go to topic 25. Topic 25 is just talking about graphing. For graphs, I recommend we use graphing calculator because it gives us very good picture of the graph. But still, with all of this information, you can graph your function. And after that, we continue on application of derivative. And after that, we go to antiderivative, which is integral, and application of integral, and then we are done. Have a good night. Bye.